Imagine this. A commercial flight takes off as usual, passengers settling in for what should be a routine journey. But then, it vanishes, completely disappearing from radar. No trace of the plane, no distress signals, nothing. 35 years later, it reappears, landing at its original destination with passengers and crew completely unaware that decades have passed. How could this happen? What scientific principles could possibly explain such a phenomenon? Buckle up as we embark on this mind-bending journey through time. Time, as we perceive it, is a linear progression of events from the past through the present to the future. However, physicists propose different models to explain the nature of time. Linear time is the everyday experience of time moving in a straight line. Circular time is a concept found in some cultures and philosophies, considering time to be cyclical, repeating in endless loops. The block universe theory posits that past, present, and future exist simultaneously, and time is another dimension like space. Linear time is the most intuitive model of time. It's how we experience our daily lives, where one moment follows another in a sequence. This model aligns with our perception of history and the future. For example, we see our lives as a series of events: birth, childhood, adolescence, adulthood, and so on. This perception of time is deeply ingrained in human culture and is reflected in our calendars, clocks, and historical records. Albert Einstein's theory of relativity introduced the concept that time is not a constant and can be affected by speed and gravity. According to special relativity, time dilation occurs at high velocities. A passenger traveling close to the speed of light would experience time more slowly compared to someone on Earth. General relativity suggests that gravity can warp space-time. Near a massive object like a black hole, time would move slower. These principles are often extrapolated to explain how temporal anomalies might allow a flight to disappear and reappear decades later without aging its occupants. Special relativity, introduced by Einstein in 1905, revolutionized our understanding of time and space. One of the key predictions of special relativity is time dilation, which occurs at high velocities. According to this theory, the faster an object moves, the slower time passes for it relative to a stationary observer. This effect has been confirmed by numerous experiments, including those involving fast-moving particles and precise atomic clocks on airplanes. For example, the Hofel-Keating experiment in 1971 involved flying atomic clocks around the world and comparing them to stationary clocks. The results showed that the flying clocks experienced less time, confirming time dilation. General relativity, published by Einstein in 1915, extends the principles of special relativity to include gravity. This theory describes gravity not as a force, but as a curvature of space-time caused by massive objects. Massive objects like planets and stars create dents in space-time, causing it to curve. This curvature affects the passage of time. The stronger the gravitational field, the slower time moves. Near a black hole, for instance, time could theoretically slow down to a crawl compared to time far from the black hole. This phenomenon, known as gravitational time dilation, has been observed in the vicinity of massive objects like the Earth, and even more so near neutron stars and black holes. Quantum mechanics, the branch of physics dealing with the behavior of very small particles, offers intriguing possibilities for understanding time and temporal anomalies. Quantum entanglement occurs when pairs or groups of particles become linked in such a way that the state of one particle instantly influences the state of the other, no matter how far apart they are. This spooky action at a distance, as Einstein called it, suggests that information could be exchanged instantaneously, potentially offering a way to bypass normal time constraints. Quantum tunneling is a phenomenon where particles pass through barriers that they seemingly shouldn't be able to. This occurs because particles can exist in multiple states simultaneously, superposition, and can borrow energy to cross barriers. While primarily observed at the quantum level, if similar principles could be applied to macroscopic objects, it might provide a mechanism for temporal anomalies. Quantum entanglement is one of the most mysterious and fascinating aspects of quantum mechanics. When two particles become entangled, their states become interdependent, regardless of the distance between them. Changes to the state of one particle will instantly affect the state of the other, even if they are light years apart. This phenomenon has been experimentally verified and suggests that information can be transmitted instantaneously, potentially offering a way to circumvent the normal constraints of time. Quantum tunneling, on the other hand, is a phenomenon where particles can pass through barriers that they seemingly shouldn't be able to. This occurs because particles can exist in multiple states simultaneously, superposition, and can borrow energy to cross barriers. For example, in the context of an electron in an atom, quantum tunneling allows the electron to tunnel through the energy barrier that would normally confine it to a specific region. While primarily observed at the quantum level, if similar principles could be applied to macroscopic objects, it might provide a mechanism for temporal anomalies. If we consider the flight's disappearance as a result of a temporal anomaly, several hypotheses emerge. Wormholes are hypothetical passages through spacetime that could create shortcuts for long journeys across the universe. If a plane were to accidentally enter a wormhole, it could emerge in another time or place without passengers realizing any time had passed. Time dilation in black holes suggests that if a flight encountered a region with extreme gravitational effects like a micro-black hole, time dilation could cause a significant discrepancy in the passage of time between the passengers and the rest of the world. Cosmic strings are hypothetical, one-dimensional defects in spacetime, postulated to form during the early universe. If a flight intersected with a cosmic string, the intense gravitational field could theoretically alter the plane's passage through time. Wormholes, also known as Einstein-Rosen bridges, are theoretical passages through space-time that could create shortcuts for long journeys across the universe. They are solutions to the equations of general relativity, first proposed by physicists Albert Einstein and Nathan Rosen. A wormhole consists of two mouths connected by a throat, and traveling through the throat could theoretically allow instant travel between the two mouths, which could be separated by vast distances or even different times. While there is no experimental evidence for their existence, wormholes remain a popular topic in theoretical physics and science fiction. Most theoretical models suggest that wormholes would require exotic matter with negative energy density to remain stable and open. Without such matter, they would likely collapse before anything could pass through. Black holes are regions of spacetime where gravity is so strong that not even light can escape. Near the event horizon, the boundary beyond which nothing can return, the effects of general relativity become extreme. Near a black hole, the gravitational field is incredibly strong, causing significant time dilation. For an observer near the event horizon, time would pass much more slowly compared to someone far away from the black hole. If a plane somehow encountered a micro-black hole or another intense gravitational source, the time experienced by those on board could diverge drastically from that of the outside world, leading to a situation where they reappear after decades without realizing it. Cosmic strings are hypothetical one-dimensional defects in spacetime that could have formed during the early universe. They are predicted by some models of particle physics and cosmology. Cosmic strings would have an immense energy density and would produce significant gravitational effects. A cosmic string could warp spacetime around it, potentially creating conditions that allow for time travel or temporal anomalies. If a flight intersected with a cosmic string, the intense gravitational field could theoretically alter the plane's passage through time. The passengers and crew of Flight 914 would face unprecedented challenges if they landed 35 years late due to a temporal anomaly. They would face temporal displacement, psychological and social challenges from suddenly being decades out of sync with their original time. Legal and financial issues would arise, addressing the status of their assets, legal identities, and family relationships after such a long absence. Medical concerns would include potential unknown health effects from exposure to whatever caused the temporal anomaly. The psychological impact of being displaced in time cannot be overstated. Passengers and crew would need to adjust to a world that has moved on without them. They would experience culture shock, adjusting to new technologies, social norms, and possibly even language changes. They would have to come to terms with the loss of years and the potential passing of loved ones. Re-establishing one's identity and purpose in a changed world would be a significant challenge. Reintegrating into society would involve navigating complex legal and financial issues. Passengers and crew would likely have been declared legally dead. Reversing this status and re-establishing their legal identities would be a complex process. Determining the status of their property and financial assets after such a long absence would also be necessary. Accessing bank accounts, pensions, and other financial resources that may have been distributed or frozen, and re-entering the job market after decades of absence would pose significant challenges. The health of passengers and crew could be affected by whatever caused the temporal anomaly. If a temporal anomaly involved radiation or other unknown energies, there could be long-term health effects. Long-term psychological support would likely be needed to help individuals cope with their experience. The reappearance of Flight 914 would have significant societal impacts. It would challenge current scientific understanding, prompting new research into temporal physics and anomalies. Governments and institutions would need to develop policies to address the rights and integration of temporally displaced individuals. The event would likely inspire a new wave of interest in science fiction and speculative theories about time travel and parallel universes. Such an event would challenge current scientific understanding and prompt a re-evaluation of established theories. There would be a surge in research into temporal anomalies, time travel, and related fields. Collaboration across physics, psychology, law, and other disciplines to understand and address the phenomenon would be necessary. Governments and institutions would need to develop new policies to address the rights and integration of temporally displaced individuals. Establishing legal frameworks to protect the rights and interests of those affected by temporal anomalies, and ensuring ethical treatment and support for displaced individuals would be essential. The event would likely inspire a renewed interest in science fiction and speculative theories about time travel and parallel universes. A resurgence of interest in time travel and related themes in books, movies, and TV shows would occur. Increased public interest in science and the mysteries of the universe would follow. While the scenario of Flight 914 landing 35 years late due to temporal anomalies remains within the realm of fiction, it serves as a fascinating thought experiment. It pushes the boundaries of our understanding of time, quantum mechanics, and relativity. Such an event would not only revolutionize science but also pose significant social, legal, and ethical challenges. As we continue to explore the mysteries of the universe, the concept of temporal anomalies reminds us of the vast, uncharted territories that still lie ahead in our quest for knowledge. In conclusion, the hypothetical situation of Flight 914 offers a rich tapestry of scientific, psychological, and societal implications. It challenges us to think beyond our current understanding and consider the profound possibilities that the universe might hold. The interplay between relativity, quantum mechanics, and human experience in the face of temporal anomalies invites us to reimagine the very fabric of reality. This was just another file open beyond our imagination. If you enjoyed the video, please like so we can get this video to as much people as possible out there. Subscribe, hit that bell notification for alerts on all our new videos, share, and comment below on topics you want us to cover on the channel. Thanks for watching and see you in the next one.